Welcome to Frequency Matters, the RF and microwave update. I'm Pat Hindle, and I'm here with my co-host Gary Lerude. In this episode, we're going to cover our June semiconductor issue, and we're going to tackle a GaN foundry survey.
Right.
There didn't seem to be a lot of information in the public about all the different foundry services, so we talk about the processes, the reliability, the back-end services, and the modeling for the open foundries that we could find around the world. So we cover Canada, US, Europe, and Taiwan. There are several Japanese manufacturers, but we couldn't find any of them that had open foundry services. And there's several in China that are starting up,
Right.
but we didn't see any of them that were quite ready for business yet, at least not
Right.
globally.
Maybe next time.
Yeah, we'll have to do an update maybe next year.
Right. Yeah, I looked on the web, and it's been several years since Microwave Journal did a survey.
Yeah, and the one we did forget was Northrop Grumman, who announced at IMS that shared services to reduce costs with shared wafer runs.
So our apologies to them.
Apologies to them, but I think we got most of the other ones that we could find. The other ones that work with strategic partners like Qorvo and GCS
Right.
didn't want to be included because they're not completely open and they didn't want to disclose all their information about their processes.
Exactly, yeah.
So there's a lot to read there. In general, efficiencies were 60 to 70%, except at the higher frequencies. And Wolfspeed kind of reported the highest efficiency at 75%, and they also had the most standard processes at 4. And then we had Fraunhofer and Ohmic had the highest frequency processes with their 10th micron process node that they use, and they're actually, Ohmic is working on an even shorter gate length for even higher processes.
Right.
And right now Fraunhofer goes to 94 gigahertz, which was the highest reported.
Yeah, I think overall I was impressed with the sort of the geographic dispersion of GaN processes. It's pretty worldwide now.
Yeah, it's proliferating and it's become very popular, so I think it's a good time for us to do this article.
Yeah.
What did you see for the technical features?
Well, we have 3 other technical features. Of course, with the phones getting more and more complex, the problem of coexistence between the different radios is a challenge. You have LTE, you have Wi-Fi, Bluetooth, GPS, and so forth. So Rode and Schwartz has written an article on basically interference testing, how to characterize devices like that. Switching to a different part of mobile, Keysight has an article on mobile radar and how do you test radar. In the old days, so to speak, people would do field tests or flight tests.
Right.
That tends to be expensive. So now with the system-level software that can simulate scenarios like radar, you can do a lot of that evaluation and development work really on the computer and then postpone any field or flight tests until later, and that saves time and obviously a lot of money.
Yeah, definitely.
So that's the second article, and then of course we have our second part of the A.J. Padar and Ulrich Rode article on metamaterials and Mobius strips.
Right.
This one covers a lot of theory, a lot of equations, but it also has some interesting applications, including gravity waves, so I think people will enjoy it.
Yeah, and they report some very impressive oscillator, very low noise at a high
Right.
frequency.
Yeah, very good phase noise performance because of using the metamaterials.
So turning to the news, I saw that EJL Wireless Research reported the growth of base station shipments last year was 16%, and that was, of course, led by China and China Mobile's deployment of TD-LTE.
Right.
But on the other hand, he expects them to decline by 12% globally this year, again led by a decline in the TD-LTE rollouts. A lot of that we saw at the beginning of the year, but that seems to have leveled off, which is good.
Right.
And then, of course, Huawei was the largest shipment of base stations for LTE and GSM, but Ericsson led the way in WCDMA and HSPA+. So a lot of information there. We hope the base station market remains strong for the rest of the year.
Right. Yeah, Earl does a really good job with his research, and I always wonder how he gets all the information he does.
Yeah, he collects it all. We saw him at IMS. He had a lot of interesting things to say.
Right, exactly. Well, kind of related to that, I wanted to spend a few minutes talking about the latest edition of the Ericsson Mobility Report, which they publish at least once a year. This one has just come out. And they try to survey kind of the market, and because they're such a major equipment manufacturer, and also they do a lot of managing of operator networks, they get a tremendous insight into the data. So their projections are that in Q1 of this year, the total mobile subscriptions reached 7.4 billion. The LTE subscriptions have gone up 150 million, so they're now at about 1.2 billion out of the 7.4. And one of the interesting things, we have a graphic to show, if you look at the subscriptions by region, if you look at China, India, Asia Pacific, and Africa, they all dwarf North America and Europe, Western Europe. So that's quite interesting, if you look at the proliferation by region. That kind of was a surprise to me. Also, as Ericsson looks forward, their projection is that actually Internet of Things connected devices are going to surpass mobile phone connections by 2018. So that would be cars, machines, utility meters, remote sensing, that sort of thing.
Yeah, that was the thing that stuck out to me, was it's a big number.
It's a big number, and the growth is basically 23% a year from 2015 to 2021. So it'll reach 16 billion of the 28 billion total connections, and we show that in a graph as well that folks can look at. Mobile video traffic, we've heard this, that mobile video is really driving the data rates and the data consumption. Their projection is that's going to grow 55% annually through 2021, and by 2021, 70% of the mobile traffic will be video. They also do an interesting report. They look kind of anthropologically and say that today's teenagers are really the ones that are driving the future networks, because they've grown up in a world where they know nothing but video streaming on their phone.
Right.
They don't know a time when that didn't exist. So that's pretty interesting, getting some insight into there. And they also talk about the need, looking at 5G, the need to harmonize spectrum, particularly above 6 gigahertz. And an interesting graphic they shows sort of the spectrum by region, and you can see it's just a lot of different frequency bands across the world. And hopefully with 5G it won't look that bad, because can you imagine taking today's phone with over 40 bands and then adding all those bands into it too?
Yeah, that would be difficult.
Too complex. So anyway, I recommend folks download that report. You can find it on Ericsson's website.
Great, and we just returned from IMS 2016 in San Francisco. So a lot of impressions from there. It was a very busy show being in San Francisco. The attendance was great. I think they probably surpassed 9,000 when the last few years have been averaging around 7,500. Of course, that'll probably drop again next year when they go to Honolulu.
To Hawaii.
Big year. Millimeter waves were kind of the big talk of the show. I talked with Dr. Khanna, who was the chair, and he says the first year that millimeter wave subject has surpassed handset amplifier design, which has always been the most popular sessions for the last few years. So you can really see that that's kind of the leading edge technology where things are heading.
Interesting.
With 5G and radar for automobiles and other applications, backhaul, they're all going up in frequency, so millimeter waves are taking off.
Yeah, we saw quite a few news announcements related to that at 60 gigahertz and 94 and also 24 gigahertz. So
yeah, that seems to be one that's kind of coalescing 24, 28 for maybe 5G. And also, I was really impressed with the amount of integration, especially on silicon processes that people are getting. Analog devices, Anoki Wave, Peregrine are really being able to integrate a massive amount of radio technology into a single chip. And we saw that with ADI's release of their software-defined radio, core chip from Anoki Wave and Peregrine. And there's several examples from global foundries partners who are achieving the same type of integration.
Yeah, that's very impressive. I would agree with both of those. The one that also struck me is sort of the proliferation of GaN devices now targeting specifically wireless infrastructure. We saw all the players, Amplion, MACOM, NXP, Qorvo, and Wolfspeed, certainly Wolfspeed acting as a foundry for some of the other players, introducing a lot of products for the base station. And so it seems like that's finally taken hold.
Right, and there's also the RF energy market, which is kind of a new emerging market, we hope, for LDMOS and GaN for sure.
Right, exactly. Amplion had a new package developed through RJR Technologies that our understanding when we talked to them is the cost of the package has gone down significantly. And of course that's going to help in terms of being able to intercept the cost targets for the RF energy market.
Yeah, I think they're targeting close to $10 for a full integrated module, a few hundred watts at the 2.45 gigahertz frequency. So that's going to be a big nut to crack.
Right. Yeah, we did see a couple of microwave ovens in the booth. So
yeah, they were cooking muffins in MACOM's booth.
Right. So it'll be good to see those hit the market. Well, let's thank our listeners, each of you, for watching this program. And we, of course, want to thank our sponsors, Mini Circuits. You can check up on their wide range of products at their website, minicircuits.com. And our other sponsor, Analog Devices. Analog had a lot of interesting releases at IMS, so you want to check those out on their website at analog.com. Thanks for watching, and we'll see you on the next episode.